Welcome to This Explainer. Today, we're going to unravel a mystery that is literally staring you right in the face, yet remains completely invisible. We're diving deep into the very fabric of existence to explore some incredibly compelling scientific arguments. Arguments that suggest the reality you experience every single day, the space around you, the ticking of the clock, might actually just be a subjective illusion.
Picture this. You're chilling on a park bench on a really beautiful evening. A guy sitting next to you asks you to describe the sky. You tell him it's a beautiful, vibrant orange. But then he stops you and asks, what does orange mean? You suddenly realize he's been blind since birth. So you try to explain it. You say it's a warm color, kind of like the warmth of a fire. But he replies, wait, isn't an orange a fruit? Fruits aren't warm. You could try explaining light frequencies or atoms, but he's never experienced those either.
So you finally just ask him, what image forms in your mind when you close your eyes? And his answer? It's simply nothing. Now that is completely shocking, because when you or I close our eyes, we don't see nothing, we see the visual static of our thoughts. Okay, let's dive into this, because this simple interaction reveals something absolutely profound. You're both human, yet the absence of just one single sensory organ means his universe feels fundamentally different from yours. Reality right out of the gate is subjective, and this subjectivity, it applies to the grandest concepts of all, space and time.
For literally thousands of years, there's been this massive, unsettled debate across philosophy and science regarding what space and time actually are. It basically boils down to two huge, colliding ideas. On one side, we've got absolutism, the belief that the universe, including space and time, is fixed, real, and totally identical for absolutely everyone. On the other side is relationalism. This is the perspective that space and time are totally unique and depend entirely on the observer. Let's actually put this to a quick test. If absolutism were true, a color like blue would look exactly the same to everyone, right? Well, we know for a fact it doesn't. Roughly 1 in 12 people have some form of color blindness. Because of this, their visual reality is entirely different from someone without it. Colors are born from light, which exists in space. So, from the relationalism perspective, this perfectly proves that the ultimate concepts of space and time must also be uniquely dependent on the observer. To see which of these philosophies actually runs our universe, we need to consult the greatest minds in history.
Part 1. The Historical Science Debate. Centuries of Conflict.
Let's move through the timeline and see how this all builds up. We're going to breeze through the centuries from the 1600s all the way to the 1900s, just to see how the scientific consensus wildly flipped back and forth between these two ideas.
Back in the 16th century, the philosopher René Descartes was all in on absolutism. He thought reality could be entirely explained by math. He actually pictured the universe as this massive 3D graph where every object could be perfectly plotted. Since you could do that without breaking nature's fixed rules, he concluded space had to be absolute. Later on, Isaac Newton borrowed Descartes' coordinates to figure out his famous laws of motion, and he doubled down, declaring that time was absolute too. As the old saying goes, time stops for no one.
But here comes the drama. Newton is famously known for inventing calculus, but the German polymath Gottfried Leibniz actually developed it too. Thanks to Newton's huge influence, though, he took most of the credit. Naturally, to counter Newton, Leibniz became a hardcore supporter of relationalism. Newton argued that particles just float around passively in a fixed, empty void of space. But Leibniz, he argued that particles have charges and they actively repel and attract each other. He proposed that space only exists because these particles are constantly interacting, so it's not a passive void at all, it's a dynamic web of relationships.
Leibniz kinda lost that battle when electromagnetic fields were discovered in the 19th century, handing the win back to Newton. But then, bam, the 20th century arrives and Albert Einstein completely flips the board over. His theory of relativity proved that space and time are actually a single relative entity. If you move fast enough, time slows down and space literally warps. He proved it's completely relative to the observer. Now what's really interesting here is that his theory relied on gravitational fields, which still needed a medium, an empty space, to exist in. So Einstein's massive breakthrough basically trapped the debate right smack in the middle.
Part 2. Emergence theory. A modern concept.
So, if the greatest physicists in history left us hanging, where do we go? Let's fast forward to right now and look at some mind-bending concepts from scientists in Los Angeles. Enter emergence theory. This is a bold new framework that tries to finally bridge these gaps. It suggests something absolutely incredible, that the past and the future actually exist simultaneously. And even crazier, it argues that the 3D reality we navigate every day is just a projection generated entirely by our own minds.
Okay, stay with me here. I know an 8-dimensional crystal sounds totally overwhelming, but think of a regular crystal. It's perfectly symmetrical, right? But if you shine a light on it and look at its 2D shadow, the shadow is totally asymmetrical. That's called a quasicrystal. Emergence theory takes this idea and scales it up. It argues that our entire 3D universe is actually just an asymmetrical three-dimensional shadow, a projection, cast by an insanely complex 8-dimensional crystal. And the basic building block of this cosmic projection? A tiny, geometric shape called a tetrahedron. And when I say tiny, I mean it's the size of the Planck length. To put that into perspective, it is 10 to the power of 16 times smaller than the absolute smallest fundamental particles in standard physics. According to this theory, these impossibly tiny tetrahedrons snap together in various patterns to build fundamental particles, which then build the entire universe. So, what does this all mean? We have a massive rhetorical question staring us in the face. If the entire physical universe is just raw geometric information, what is making the actual choice to arrange it into the reality we see? Information needs meaning, and meaning requires comparing patterns. Think of the letter Y. You only know it's a Y because your brain compares the lines to the empty space around it. So, what is doing that comparing for the universe?
Part 3. Consciousness and Quantum Reality.
The answer to that grand question brings this whole cosmic narrative right back to your brain. The missing ingredient in the universe's geometry is you. To make a comparison, you have to make a choice. And choice, that only comes from consciousness. So the crucial point is that your consciousness isn't just a passive camera recording the world. The physical reality around you is an active process, born directly from your consciousness interpreting information.
And scientists aren't just pulling this out of thin air. They're basing it on hard quantum mechanics, specifically quantum entanglement, which just won the Nobel Prize in Physics back in 2022. Before quantum particles are observed, their properties are completely undecided. They just float in a cloud of infinite mathematical possibilities called a superposition. But the exact millisecond a conscious observer looks at them, boom, that cloud collapses and their physical properties lock into hard reality.
Once those properties collapse into existence, they're fed straight into your unique brain. You have entirely unique, complex neural circuits processing that raw data. Your brain takes that collapsed quantum information and builds your personal version of reality. And this brilliantly illustrates exactly what we talked about earlier with the blind man. Because your hardware is entirely your own, your reality is 100% subjective. Your consciousness literally plays a central role in manifesting matter.
Which leads us to a pretty profound takeaway from our source material. The solid, fixed reality you walk through every single day, the one we all assume is absolute, isn't absolute at all. It's relational. It's this fluid, ongoing relationship between the raw data of the cosmos and the active processing power of your mind.
Part 4. The Ultimate Simulation.
Now, if emergence theory really is the framework that bridges Einstein's physics with quantum mechanics, it opens the door to a very futuristic and honestly slightly chilling possibility. Think about the tech implications here. If reality is ultimately just information processed by a consciousness, it can theoretically be recreated by a computer. In fact, scientists have already successfully simulated an entire helium atom, and they genuinely believe that scaling this up to simulate complex molecules, everyday objects, and eventually human brains is just a matter of time.
Which leaves us with one final massive question. If the universe is just a projection of information, and we are already learning how to simulate the fundamental building blocks of matter in our own computers, is it possible that the reality we are experiencing right now is already a simulation? Are we simply living inside a simulated world? It's a thought that definitely forces you to question your very existence. Thanks for tuning into this explainer. Keep questioning and keep learning.